Hello children. So welcome to aimsindia's online classes. Today from physics subject measurement topic we are going to discuss. Our today's concept is regarding density children. We are going to learn about density. So density means how much mass we have taken and what is the volume. What is the volume we have taken? That mass by volume, this ratio, mass by volume, this ratio 0.5 gram per ml. This ratio is called density. Means mass of the object per unit volume. Suppose mass is here 200 grams. Mass is here 200 grams. Its volume is 400 milliliter. If we divide, we will get 0.5 gram per milliliter. Means mass 0.5 grams per milliliter means unit volume. Like that, mass per unit volume is called density, or ratio of mass and volume is called density. By using this property, we can tell whether an object like this block, whether it will sink in this fluid or whether it will float like this. Based on density property, whether it will sink or float, that we can decide. Next one. Density here. So objects of same size may have different masses, or objects of same masses may have different sizes. Why means different kinds of material have different densities. If you take 1 kg of cotton and 1 kg of iron, so here 1 kg, but here 1 kg. Both the masses are same, but what is their size different? It's because of density. Because the cotton density of cotton is less than density of iron. So because of this density property, though they are having same mass 1 kg and 1 kg, but their sizes are different. It is because of their density. So density means it's a property of a body that tells about arrangement of molecules in a given material, or mass per unit volume is called density. If a body mass is m and body volume is v, then density equals to mass by volume, d equal to m by v. So this is the formula for density. And the SI unit of density is, because we are telling density equal to, density equal to mass by volume, whereas the unit of mass is kg in MK system, kg. Unit for volume means length into breadth into height, means length into length, L cube, or sorry, length is measured in meter cube, kg per meter cube. So kg, we can write kg per meter cube, or meter cube will go up, kg m to the power of minus 3. So this is the SI unit of density. The CGS unit is, instead of kilogram meters, we will take gram centimeter to the power of minus 3. Gram centimeter to the power of minus 3. So here the relation between this unit and this unit is 1 gram per centimeter cube equals to 1000 kg per meter cube. 1000 kg per meter cube. That is the relation between them. Because how we have got this value means, so 1 gram per 1 centimeter cube. 1 gram means how much? 1 by 1000 kg. 1 by 1000 kg by 1 centimeter, how much? 1 centimeter equals to 1 by 100. 1 by 100 meter. whole cube. Means it will become 10 power 6. This is 1 by 10 cube, 1 by 10 power 6. It will become 10 power 6 by 10 cube. 10 power 6 by 10 cube, cancel. So 10 cube. 10 cube. We have converted into kg meter cube. So 10 cube kg meter cube. 10 cube equals to 1000. So in this way, 1 gram per centimeter cube equal to 1000 kg per meter cube. That means this CGS unit, this is SI unit. 1 CGS unit of density equal to 1000 SI units of density. That is the relation. Means in CGS system, the unit is 1 gram per centimeter cube. It is equal to 1000 kg per meter cube in SI system. But both the values are same. So density of any object, how to find, children? We can find it experimentally with the help of mass and volume. So mass is measured by physical balance. Mass is measured by physical balance for accurate measurements, while volume can be measured with the help of measuring cylinder or pipette, burette, like that. So many measuring cylinders we have. With that, we can measure the volume. So the density can be calculated by depending on these two values. Just taking their ratio, we can find out what is the density. So for finding density, we make use of an apparatus called specific gravity bottle. Specific gravity bottle, it can be used to find density of a liquid. Density of a liquid. Next. So determination of density of a solid by using measuring cylinder. Not liquid. Here we are finding the density of a solid by using a measuring cylinder. So to find density of solid, what we need? We need some mass and volume. So mass can be measured by, mass M can be measured by physical balance. To find volume of solid, so we will take a measuring cylinder with the fixed volume of water. We will take a measuring cylinder with the fixed volume of water. Like this. Measuring cylinder with fixed amount of water that we will take. And mass we will measure with the help of physical balance. Mass we can measure, and the volume of, we have to take a known quantity of liquid column. So now let the mass be capital M and the volume of water be V1. Now the solid is tied to a string and is lowered into the measuring cylinder such that it is completely immersed in water. So here, with the help of thread, we are suspending a stone into the fluid we have taken such that total it will be immersed completely. It will go into the water completely. Because of this block, the water level will rise. The water level will rise. So here, the new level of water V2 is noted. Before stone, it was V1. After suspending stone, it was V2. If you take the difference, V2 minus V1, it gives volume of the solid. Volume of the solid. So by taking the difference of without suspended mass and with suspended mass, we can find the volume. So mass is already 100 grams. Mass already we have calculated. Now volume also we have got. Now mass equal to, density equal to mass by volume. Mass 100, density according to this diagram 200 centimeter cube. Mass 100 grams. Cancel, 1 by 2 means 0.5 gram per centimeter cube. Like this we can calculate density of a solid with the help of another liquid. Next. determination of density of a liquid using specific gravity bottle. So density of a liquid we have to find by using specific gravity bottle. How to find that we have to see once. So this is the specific gravity bottle, children, like this bottle, or we call it as relative density bottle. Specific gravity bottle or relative density bottle. So here, children, the specific gravity bottle or density bottle is a small glass bottle having a close fitting ground glass stopper to its neck. It's only a small glass bottle having a close fitting and which has a ground glass stopper at its neck. So the stopper has small capillary tube. Capillary means having holes. Small tube having small holes, that is called capillary tube. Here, when the bottle is completely filled with the liquid, excess liquid rises through the capillary tube and drains out, which ensures that equal volumes of different liquids fill the bottle. So here with the help of capillary tube, we will pour liquid into this. First liquid, second liquid, third liquid, up to the neck. Excess liquid will come to what they have told, rise through capillary tube. Excess liquid rise through capillary tube. Okay, children. So how to do the experiment, children? So first, take a clean, empty density bottle with stopper, is weighed in a physical balance with all the parts. If it is weighed in a physical balance, let the mass be m1. Mass be m1. So now this density bottle is filled with distilled water and stopper is inserted. The bottle is wiped from outside so that it is dry. Means we will take precaution in such a manner that no wet particle is attached to the density bottle. So total it is dry, like that we will see, so that we will get the value of accurate what is there in the density bottle. That value we will get. So previously, empty density bottle we have weighed and we kept it as M1. Now we are pouring some liquid and we are naming its mass as M2. Next, water is poured off and the bottle is dried again. Next, now bottle is filled with the given liquid, another liquid whose mass is M3. So now let's see how to find density in this case. So here, mass of empty bottle M1. Mass of empty bottle M1. Mass of empty bottle plus water. With water it is M2. Instead of water, if you want to find the density of alcohol or density of pineapple juice, like that, any juice. So mass of empty bottle plus whatever object's density we are going to find. So that object to be mentioned here. Mass of empty bottle plus liquid, because we want to find the density of liquid. So let it be M3. So empty bottle M1, empty bottle with water M2, empty bottle with required liquid M3. So now if they ask what is the mass of only water? Only water means from M2, M1 we have to remove. So then mass of empty bottle will be cancelled. So M2 minus M1. So what is the volume of 1 gram of water? It is always fixed, 1 centimeter cube. So if 1 gram of water is 1 centimeter cube, then what is the amount of water here? M2 minus M1. So what is the volume of water, total water? M2 minus M1 centimeter cube. Okay. Next, volume of bottle. What is the volume of bottle? Volume of bottle. So the volume of water, it is coming. Bottle cancel. Volume of bottle means we need only volume of bottle because it is completely filled with water. So how much water volume is there? That much will be the volume of bottle. Volume of bottle. Next one, volume of liquid. Because same amount of water, same amount of liquid we have taken. Complete density bottle is filled with first with water and liquid. Both the volumes are same. So volume of liquid also will be equal to M2 minus M1. Next one, what is the mass of only liquid? Mass of empty bottle plus liquid M3. Empty bottle M1. What is the mass of liquid? M3 minus M1. M3 minus M1. Like this we can write. So now, density of liquid. Density of liquid equals to mass of liquid by volume of liquid. What is mass of liquid? M3 minus M1. What is the volume of liquid? Because volume of liquid equals to volume of water equals to M2 minus M1. So that equal to M3 minus M1 by M2 minus M1. So density always measured in gram per centimeter cube children or kg per meter cube. That is the unit of density. Okay, children. Next, the density of liquids and gases changes with the change in temperature. So with the rise in temperature, the molecules will go. Previously, the molecules are close to each other, but when temperature rises, when there is rise of temperature, because of temperature, these molecules, they will disperse, they will expand. If they expand, volume will increase, mass will be same, but volume will increase. So if volume will increase, this ratio value will decrease. This ratio, it is the value of density. Okay, so density will decrease. Density will decrease, and vice versa. If there is a fall of temperature, density will increase. Okay, the convection currents you will be studying in your higher classes in liquids and gases are formed due to decrease in their density with rise in temperature. In liquids and gases, the flow of the atoms or molecules will happen because due to decrease of density with rise in temperature. Next we have about relative density, children. So relative density means if the density of a substance is compared with the density of water to give a number, that is called relative density of substance. Because if we divide density of substance by density of water, density of substance unit kg per meter cube, density of water unit kg per meter cube, or both of them can have gram per centimeter cube. So all units are same here. So units gets cancelled. We will get only a number. So density of substance by density of water, it's only this ratio is only a number. So relative density also, it doesn't have any units. it is only a number. It's just a number with no unit. One minute. So actually, densities table is there. It is not provided here, but you have to go through the table of densities, so that while calculating this relative density, that values will be helpful. So relative density of iron. So density of iron by density of water. So density of iron, how much? 7,800. By water, how much? 1,000. So the relative density of iron is 7.8. Like that we can calculate. So what does it mean actually? Relative density 7.8 means what does it mean? So in the numerator part, what we are having? In the numerator parts, density of substance we are having. In the denominator part, density of water we are having. So now relative density 7.8 means what is the meaning? Because this is of iron, the density of iron is 7.88 times more than water. Like that, whenever they are comparing relative density, they compare with the relative density of water. So iron density, relative density is 7.8 times more than water. Next. So determination of relative density of a liquid. So it can be determined by relative density bottle. It's a small bottle made up of glass. It has a stopper with a fine hole through which capillary tube we can send inside. This relative density bottle is used for finding mass of equal volumes of liquids. Mass of equal volumes of liquids, because whatever relative density bottle we have, this bottle first time filled with water completely, second time filled with liquid, means both of them having same value. Okay, children. That's all for today, children. So let's continue the class tomorrow. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.